OK, the tour continues. So we talked about model view controller. We talked about models. And we're going to talk about controllers next. And really, the important thing about controllers is this special concept called REST that is one of these things people argue a lot about. But the basics of it are not difficult to understand and really not that difficult to get right. And the question that REST really answers is, given that we believe service-oriented architecture is a beneficial way to organize services on the web, what are some design decisions that would allow our app to more readily support being part of a service-oriented architecture? Or another way to look at it is, what are poor design decisions that would make it difficult for an app to participate in a service-oriented architecture? So continuing our tour, we're still here in this middle tier where the action happens in the app server. And we're now going to look at controllers and the relationship between controllers, URIs, and REST. So REST stands for Representational State Transfer, another sort of $20 word. Roy Fielding wrote about this in his PhD dissertation in 2000. And the words I'm using here are not the ones he used, but I'm trying to convey the essence of what it is, because the idea is relatively simple and straightforward. The idea is, don't think about a URI as naming a page or naming an action that you're going to do. Think about it as naming a resource and a thing that you want to do to that resource. And the word resource is very broadly defined here, right? The idea is that a resource could be a movie and all the information about that movie in Rotten Potatoes. A resource could be the list of all movies that we know about. A resource could be the list of all movies that match some criterion, like having a particular string be part of their name or having a particular MPAA rating. Those are all resources. In fact, a resource can even be the response of trying to create a new movie. When I create a new movie, I've created a new resource, and all I need to know was, did creating that resource succeed or not? So start thinking about the way that your URIs are expressing resources and things that you want to do to them in a self-contained manner. And in fact, the Wikipedia article for REST, I don't know if it still contains this phrase, but it once did. REST is really an after-the-fact description of the features that made successful web services be successful. So if you have a service in the sense of a service-oriented architecture service whose operations follow these principles, then we say it's a RESTful service and it has a RESTful API. And in such a service, RESTful URIs name the operations that you do and the resources that you do them on. This is much easier to do if we show a concrete example. So to do that, I'll give a very brief introduction, because we're going to talk about this in more detail when we go back to exploring Rails, to how Rails allows you to set up mappings between URIs and the controller. Because remember, the controller is where all the action originates, right? When a request comes in from the user, a controller is where it hits first. And when there's stuff ready to be returned to the user, the controller mediates that interaction. So what does Rails give you to help you do this? A route in Rails is basically a mapping from a URI and an HTTP method, like get or post or put, to a controller action. Here's a few examples that are RESTful. If I say something like get/movie/3, this could be a way to represent whichever movie has the ID 3 in the database, I want information about it. Now, don't worry for the moment about the fact that most end users are not going to know the IDs of things in some random database behind your app. Think it just in terms of, assuming that we know the resource and it has a unique name, how do we construct resource requests that name the thing that we want to operate on and what we want to do to that thing? Here's another example. When I submit a form and I post to the URL/movies, the interpretation can be, I'm creating a new movie, and here's the data that I'm going to use, the data to populate the attributes of that new movie object. I could also say, I'm going to define put/movie/5 to mean, if there's a movie whose ID is 5 and it exists in the database, here is some new data to replace the current attributes of that movie. Now, if you've done some web programming before, you probably already are getting ready to say, web browsers don't support put and delete. Even though HTTP defines them, web browsers only support get and post. That is true, but first of all, Rails provides some interesting machinery to essentially simulate doing put and deletes. And why would you want to do that? Because the way that we want to think about our apps is not, this is a user-facing app that's a bunch of web pages. We want to think about it as, this app is a collection of services, things that you can do to resources. One way to interact with those resources is to serve web pages with which human beings interact, or monkeys, or whatever. But another way to interact with that service is, I could write an application that just makes HTTP calls against my app. In fact, in an upcoming homework assignment, you're going to do just that. You're going to make HTTP calls against the Oracle of Bacon website. More about that in a future lecture. So what does the routing subsystem give you? Basically, it gives you a bunch of machinery to take a URI and a method, right? Collectively, those two things together are a route, and to map those to the correct controller action so you know where in your app the code is going to be called to handle that URI. It provides a bunch of helper methods that you can use to generate the correct URI given a controller action. So again, don't think about when you're serving a page to the user, it's going to have some links to allow the user to do other stuff. You don't want to think in terms of links. You want to think in terms of what new operations on resources am I going to expose to the user? And Rails provides machinery for you to take that information, and it will generate the correct URI based on your stated scheme of how you want to map your routes. If you include parameters, if you looked at the textbook section on URIs, you can embed parameters in the URI. There's machinery to pull all that stuff out so that your controller method can get at it. And there's built-in shortcuts because the CRUD actions are so common. There are built-in shortcuts to generate automatically all of the CRUD routes for you so that you don't have to actually specify those mappings one by one. So for example, when you create a new app and you say, here's a thing in my app, movies are a thing. Movies are a resource that I'm going to manipulate. For free, Rails will define all of these routes and create mappings to standardly named methods in your controllers that are going to handle those actions. Now, of course, you can create your own routes as well. You're going to have a lot more things in your app than just basic CRUD on every model. That wouldn't be a terribly interesting app. But the idea that you get these for free and that the way you get them is by saying movies are a resource really is what exemplifies the thinking that apps are really a collection of RESTful services. And oh yeah, a way that you can interact with it is you put a web page in front of it. So what exactly happens, according to the scheme, if I have an HTTP request like get/movies/3/edit, right? That's one of the automatic routes that's created for you by Rails that means invoke the edit action on the controller associated with that resource. What goes on behind the scenes when your browser generates that request and it hits your Rails app? Well, the first thing is that Rails routing subsystem will match the URL. It will try to match against one of the routes that's in the route table. In this case, it matches the route that I've highlighted in yellow because the tokens that begin with a colon are like a wildcard. So what will actually happen is the route will match, and the ID portion of the route will be set to match the number 3 in the URL, the URI. So it'll parse the wildcard parameters. Those actually end up getting put in a hash that your controller can access for free. Then it'll dispatch to the edit method. Why? Because the route specifies that if the URI matches this pattern, it should go to the edit action, the edit Ruby method in the movies controller. And if I want to then, as part of my controller action, I want to generate a view that will cause the user to submit a form to update that movie. So what does that form have to contain? It has to contain a submission URI that looks like the one that's highlighted in yellow here, right? I need a form that will cause this to happen when submitted. The bad old school way that you would do this is you would manually embed in your view, in your HTML view, you would embed a hard-coded URI to do that. What you do in Rails is you say, what I want to do is give the user a URI that will cause an update to movie ID 5, and then it will generate the URI for you. Why would you do it this way? Because if your route naming scheme ever changes, you don't want to have to go through and manually change all the hardwired routes that you created, right? You want to be thinking in terms of resources and operations on resources, and the mapping really is incidental. That's why that part is handled for you. We're going to have a lot more to say about routes and controllers when we do our walkthrough of Rails apps, but I wanted to give you a flavor of what restfulness looks like when you implement it in practice.